To today's class is Math with Joy. Now, if I tell you to walk 5 kilometers from your house, do you know exactly where to go? If I say just walk 5 kilometers from your school, from your house, from your church, do you know exactly where to go? Of course, you don't. Now, you also need to know the direction. Ma, do you say I should walk 5 kilometers? Is it to the east, to the west, to the north, or to the south? And that is where bearing and distance come in. So today we're going to be looking at bearing and distance. So if you are in year 9 or even year 8, or even you are in the senior secondary, but you still have issues with basic bearing and distance, the foundation of bearing, please come close. This class is for you. Now, what is bearing before we proceed? Bearing simply tells us the direction of an object. So the science student will say it is a vector quantity. It tells you the direction. 5 kilometers where? To the north, go up, go right, go left. So when you say all these things, there is a direction, and that is bearing. Okay, so now in this bearing, you should know that the basic thing is that it is not just telling you direction of an object, but that direction begins from a point. There is always a starting point. All right. Now, if I say move 5 kilometers from your house, and then I said, okay, walk 5 kilometers from your house to what? To the left. Now, what do you do? Come out from your house. Now, that house is your starting point. So in bearing, always note that there is what? A starting point before we talk about what? The direction of the object. Very important. Now, distance simply tells us how far the point is from another. Man, I walked 5 kilometers from my house to the market. So distance is telling us what has been covered. It can be in kilometers, it can be in meters, and so on and so forth. Okay, now putting bearing and distance together, they tell us exactly where to go. All right. So now imagine if I say a car, a car travels 10 kilometers on a bearing of 60 degrees. A car travels 10 kilometers on a bearing of 60 degrees. Okay, so now this 10 kilometers tells us the what? The distance. Then this 60 degrees tells us the bearing. So, okay, the car travels 60 kilometers. Oh, that means it is where? Here. All right. Okay, the car travels 60 kilometers. That is in the northeast direction. Okay, and the distance the car covered was what? 10 kilometers. Okay, so that is just what bearing and distance is basically all about. So now together they help us to describe the exact position of movement from one point to the other. Now, before we can proceed in that, let's look at the coordinates because that is exactly what we use in bearing. Okay, so now looking at the coordinates, so you have your four cardinals, the north, the south, the east, and the west. So this, of course, is not new to you, right? Okay, so now let me repeat the same on this end, the north, the south, the east, and the west. I'm going to be using both of them simultaneously. Now, in bearing, before I talk about bearing, if I ask you to measure angle 50 degrees, for instance, what do? You use your ruler, then you draw a horizontal line. You place your protractor and start this way, right? And then you indicate your angle what? 50 degrees. Is that correct? So now what does that tell us? It tells us that we measure angle on the horizontal from where? In the what? Anti-clockwise direction. This way. That's how we measure angle. Okay, having known that, coming to bearing, bearing is saying the opposite. Now in bearing, we measure angle what? In the clockwise direction. Clockwise. In the clockwise direction from what? From the North Pole. So in as much as angles are measured on the horizontal, in bearing, we measure bearing from the what? On the vertical pole. Are you getting me now? Good. So now angles are measured in the clockwise direction from the North Pole. So what does that tell us? It tells us that if angles are measured from here, watch me. So that means from here, if I start, if I didn't make a movement, is there any angle formed? If I'm starting at a point, my bearing is 0. All right. So bearing takes place when movement has been done or when movement is being done. Okay. So now, anywhere I am standing is my north until I begin to move. Right. So now, as I'm standing, I have 0, 0, 0 degrees. Okay. So now from that 0, 0, 0 degrees to this place, this is the first quadrant. Okay. And that's from 0, 0, 0 to what? 0, 9, 0. So we have angle 90. So from here to here is the second quadrant. So this is 0 degrees to 90 degrees. So this second quadrant, I have 90 to 180. And then here, each quadrant is 90 degrees. Take note because each is 90, angle 90. Can you see it? So here I have my third quadrant. So I have 180 to 270. While here is my fourth quadrant. So this my fourth quadrant. I have 270 to 360. Okay, now here, given that, so here, if I have a position here, in between the north and the east, it is the northeast. Any position here in between the south and the east, you see the way I call them? The vertical before the horizontal. I don't say east south. You heard somebody say east north or east south or west south. You call the north before the east. That tells you that the same way you call them is also the same way you locate them. Okay, so I have southeast, then I have a position here, and that is my southwest, and then I have my position here, and that is my northwest. Now, you see in this first, look at the first figure. Let me call this fig 1, and then let me call this fig 2. So if you look at fig 1, you'll see that I have just 4 quadrants. And since angles at a point is 360, the 4 quadrants are 90 degrees each. So in fig 2, you will see that I have 8 quadrants. And since angles at a point is 360, each quadrant will have angle 45 degrees each, right? Now, this second figure is what we call the compass bearing. The compass bearing. That is when you locate positions or call positions depending on where they are. You say, I've gone 30 degrees northeast. I've gone the same 30 degrees. Another person will say, me, I walked 30 degrees southwest. The same 30 degrees, another person will say, me, I walked 30 degrees northwest. So it is called the compass bearing. Okay, now having known that, this first figure, I'm going to be interpreting each quadrant one after the other. And I believe that if you watch this video to the end and understand this tiny concept, you will be able to solve any question on bearing at any level. So now let's pick these quadrants one after the other. So now in the first quadrant, we have remember we've established that in each quadrant we have angle 90, right? Okay. So we have the north, south, east, and west. So now, since angle starting from here is 0, it means that we have 0 to 90 degrees here, right? So now any angle less than 90, we call them acute angle. We've already known that, right? So let's call here theta, where theta is an acute angle. Now this theta, for any bearing question you solve, you must know your theta. It is a must. It is very fundamental in bearing. You must know your theta. Okay, let's roll. Now, since angles here are called theta, that means there's nothing to look for. We're not looking for anything. Okay, so if any angle falls under the first quadrant, we've known our theta. All right, remember I said for any question you're going to be solving, you must know your theta. So if it's in the first quadrant, am I looking for theta again? I don't need theta again because that is theta given to me. So angles in this first quadrant, examples we have 031 degrees, 071 degrees, 089 degrees, and so on and so forth. Now, if you notice, you will see that I give them in 3 digits, right? So in your exam, except you are asked to give your bearing in 2 digits, we always use what? The surveyor bearing. So another name for this 3-digit bearing is the what? The surveyor's bearing. So when we look at examples, we'll talk about it more. So this is the one that surveyors use and not the compass bearing. Okay, so that's giving bearing in 3 digits. So if the bearing is now acute, acute is 2 digits. What do? You start with 0 just to make it up to 3 digits. So now for the first quadrant, I believe it's clear. Angles there, they are referred to as theta, and I've given you examples, right? So we don't need to find theta again when the bearing or the position is in the first quadrant. Now, when it's in the second quadrant, what happens? In the second quadrant, this is my second quadrant, right? So now it means that the position or the bearing will land here inside. For any bearing given to you, if it's in the second quadrant, this is where it will land. From the north, bam, this is second quadrant. Now we said that in the second quadrant, we have angles 90 to what? To 180. So in the first quadrant, our theta, we're not looking for it. So if we need to solve questions on bearing that fall in the second quadrant, the question is, how do I find my theta? First of all, before we talk about finding our theta, what are the examples of angles that fall in this quadrant? We have, since angles, we are using the surveyor bearing, we have to give them in 3 digits. We have 099 degrees, we have 112 degrees, we have 135 degrees, and so on and so forth. Now, like I said, the question is, how do I now find my theta? Now, to find my theta, recall that in bearing, we measure angles on the vertical pole, right? So what do? We measure this angle. This is our theta. This is the acute angle that this position makes with the vertical pole, and that is our theta. So now the bearing that falls in this quadrant is from here to here. So that bearing plus theta will give us 180. That is what? Angles on a straight line. So to find this bearing, which is from here to here, we remove theta from 180. Okay? So to find bearing or position of angles in the second quadrant, remember I said you must know your theta. Okay? So now our theta is that angle that the vertical pole, whether it's in the south or it falls in the north, that angle that the position makes with the vertical pole. So now, locating our theta, which is an acute angle, remove it from 180. The rest of the angle is that bearing, because bearing must be measured from the north. Okay, so the bearing is this angle measured from the north to this position. And that is it for the second quadrant. Okay, So now moving to the third quadrant. Moving to the third quadrant, so since angle is measured from the North Pole, we'll measure from the north down. This is our third quadrant. Okay, so this is the position. If any angle falls, if any bearing falls in the third quadrant, it will look exactly this way. Now, what did I say before? First of all, angles in this third quadrant range from what? From 180 to 270, right? Now, somebody will be asking, in the second quadrant, we used 180 because angles there range from 90 to 180. In this third quadrant, why are we not using 270? Let me answer you before I proceed. We are not using 270. Note that this is your 180 to 270. Now, you will see that the 270 is touching the horizontal, and we do not measure bearing on the what? On the horizontal pole. So since we do not measure bearing on the horizontal pole, that is the simple reason why we do not use 270 when your position is in the third quadrant. All right. So now, since angle 270 lands on the horizontal, what do we now do? First off, example of angles within this quadrant are 181, giving them in surveyor bearing, 213, 260, and so on and so forth. Okay, now since we do not use 270, and I've told you the reason, what now do we do? If you watch, you will see that from this North Pole to the South Pole, we have 180, that is angles on a straight line. And then here, which is the additional after the 180, and the position is the angle, checking the angle that the position makes with this South Pole, which is also a vertical pole, we call it our theta. Do you still remember what I said earlier? So, and from here to here, we have our 180. So what does that tell you? It tells you that any bearing that lands in this third quadrant, to find that bearing, remember I said you must know your theta, add 180 to theta. If you add 180 to theta, you find the bearing if it is in the third quadrant. So if the bearing is given and you are looking for theta, what will you now do? For instance, let's say the angle is 260 and you are told that the bearing that A makes with B is 260. You already know that 260 falls in the third quadrant, right? So that 260, you split it into 180 and theta. How do you split? By removing 180 from 260. Okay, so if you now remove 180 from 260, what will be left will be what? 80 degrees. So it means that your theta will now be what? 080 degrees. I hope it's clear now. Okay, so now very quickly, moving to the fourth quadrant. Moving to the third quadrant, we move from the north, first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, now we've established that angles within this quadrant are from 270 to 360 degrees. Okay, now the next question is, what are the examples of these angles in this range? We have 281, we have 299, we have 334, and so on and so forth. Now the next question, where will my theta be? Will my theta be here or will my theta be here? Now if I look at, okay, will my theta be in I or will it be in II? So if you take I, you will see that I is the position, is the angle that the position makes with the horizontal plane, or with the horizontal pole rather. But if you now measure the angle that the position makes with the horizontal, it is no longer bearing, because bearing is measured on the vertical pole, right? So now the vertical pole that is closer to or close to the position is the north pole. So that is the angle you will measure. And if you measure that angle, adding it to the bearing, that will be a complete revolution. That's 360. So now this is my theta, right? That means to find the bearing that falls under here, I will remove theta from 360. Are you getting me now? So now let's even assume that this angle, let's say, is 334. So how will I find my theta? I will remove the 334 from 360 and I will find my theta. So now I believe that with this illustration, you will be able to solve questions. Okay? So now let's differentiate between this 2-digit and the 3-digit bearing before we talk about finding bearing. 2 digits, okay, or let's use a standard name. Let's call it differentiating between the compass in bracket 2-digit bearing and surveyor in bracket the 3-digit bearing. There are other names. Okay, now I'm gonna be giving let me use 45. Just note this before we move on. In bearing, there is nothing like 45 degrees. What did I say? In bearing, you don't write angles this way. It doesn't show anything. If you write 45 degrees, you're not referring to bearing, but maybe you're referring to just angles normally, which you can just measure in the what? In the anti-clockwise, on the horizontal. But in bearing, if I say 45, what does it mean? Does it mean 45 degrees northeast? You cannot say that it means 45 degrees, you can't just, it doesn't tell anything, right? So this 45 degrees, using it as our illustration, if it is in compass, how do I write 45 in compass bearing? In compass bearing, I write 45, I can write it as 45 degrees northwest. Note that this 45 degrees northwest is different from saying 45 degrees northeast, and it is also different from saying 45 degrees, let's say, southeast. Okay, now before I come to the surveyor bearing, let's represent these ones I have written. So now if it is 45 degrees northeast, if I'm to use compass bearing, 45 degrees northwest, starting from there, this is my north, this is my south, this is my east, and this is my west. So 45 degrees northwest will be in this quadrant where I have northwest. And since angles are measured in the vertical pole, I will indicate it here. So this is the only time I can write this way. So this shows, I won't put 0 here, because if I put 0, that means I am contradicting, I'm using 2-digit and 3-digit at the same time. So this is the only time. So seeing this 45, I will know that, oh, this 45 is not in the first quadrant where acute angles are. Okay, rather that it is my theta. Are you getting me? So it shows that this bearing or this position falls in the fourth quadrant, but I am giving the acute, that's the theta. Okay, so now this same 45 degrees northwest, if I were to write it in surveyor's bearing, what will it be? That means, remember, I should start from the north in the clockwise direction till I get to this position. Do you see it now? Good. Remember I said you must know your theta. Have you seen why? Good. Now I know my theta. What's my theta? 45 degrees. So what's the next thing to do? Remove 45 from 360 since it is in the fourth quadrant. And if I remove 45 from 360, I am going to have 315 degrees. So now it means that 45 degrees northwest in compass bearing is the same thing as 315 degrees in surveyor's bearing. Are you getting me now? This same 45 degrees, if it is to be in northeast, where will it be? This same 45 degrees in northeast, 45 degrees, this is cancelled. 45 degrees in northeast, this is my north east. That means the position will be here. Okay, so now since my angle is to be measured, okay, so this is my 45 degrees. Remember I said I will not put 0 since it's 2 digits. All right, so now this 45 degrees, if I'm to have it in 3 digits, I will still start from the north. So the difference between 45 degrees northeast in compass and 45 degrees in surveyor is that this is the same thing as 0 for, since it falls in the first quadrant, start with 0 to make it up to 3 digits. And then lastly, if it were to be 45 degrees southeast, 45 degrees southeast, so this is my south, this is my east. So if I have 45 degrees, it will be here. And then the angle I'm looking at is the angle that the vertical makes with the position. So I have 45 here. Okay, good. Now, if it were to be in, this is my compass bearing, 45 degrees southeast. Okay, so now if it were to be in surveyor's bearing, what do I do? That means I'm to measure this angle from the north until it gets to this position. So now remember I've known my theta, right, which is 45. Good. So my theta plus this bearing makes an angle of 180. So how do I find it in surveyor's bearing? I simply remove my theta from 180 because it's in the second quadrant, and that will give me what? 135 degrees. So that means 45 degrees southeast in compass bearing is equivalent to 135 degrees in surveyor's bearing. So are you seeing how these things move, how they relate? Okay, all right. Now, so before we find bearing, how do we locate positions? Fine. So let's look at these two. So to locate position of bearing, 314, what comes to your mind? To ask yourself, which quadrant will 314 be in? That should be in the fourth quadrant. So now, if it will be in the fourth quadrant, most times you consider your what? Your theta. So this is the position. Okay. So if this is the position, what will my theta be? I want to write theta here because if I write 314, where will I write it? Will I write 314? It will be so, it will look so messy. So I would prefer to write the what? The acute angle of it. Okay, so that means I will find the acute by removing that 314 from 360. And if I remove it, I will have, this is 6. Okay, so I will have 46 degrees. So remember, I'm working with surveyor's bearing. Okay, so this is it. I've located this position. So for the 219, I will check which quadrant will 219 fall into. Not first, not second, then it should be third. So this is it. So it means that the whole of this is 219. But then if I write 219, it will be somehow. So I prefer to write the acute. So what will be the acute? The whole of this is 180. So remove that 180 from 219 to find my theta. So you have 9. 11 minus 8 will give you 3. So you have your theta to be 39 degrees. So that is actually how to locate positions. So now very quickly, let's look at finding bearing. Let's solve a few questions, and with that, we come to the end of today's class. And with that, we come to the end of today's class. But that doesn't mean you should end learning bearing or solving more questions exactly where we stopped. Solve more and let me know if you encounter any issues solving any one. So the first one, a boat travels from A to B on a bearing of 60 degrees for 8 kilometers. So how do you locate that? A boat travels from, Now, there are two words you need to note when locating positions of bearing. You see from, you see to. Good. So now a boat, let's locate 60 degrees first. So I have my 60 degrees here. So what's the distance? The distance traveled is 8 kilometers to another position. Now the question is, where is my A? Which one is my A? Which one is my B? Let's read the question again. It says a boat travels from. So that from is our starting point. So it is that from A that it traveled 8 kilometers to B, making an angle of 60 degrees. So this is where our B is. Did you see that? Good. So now moving over to the second question. The second question says, if the bearing of A from B, the bearing of A from, remember I said it, take note of this word. If the bearing of A from B is 119, so 119 should be in which quadrant, guys? It should be in the second quadrant, right? Okay, so now locating it in the second quadrant, I have another position here. So now remember, okay, I said I prefer working with um the acute version, the acute angle. So this is the bearing. So 119, I will have 180 minus 119. And that will give us, this is 1, this is 6. So I have 61 degrees here. Good. So now the next question is, where is my A and where is my B? Now, if the bearing, they say the bearing of A from B, from, so this is our B. So it is the bearing of A from B that is 119. So we have to find the bearing of B from A. Beautiful. Now to find the bearing of B from A, we will measure the bearing from the north until it gets to the position. So which quadrant did it land on? It landed in the fourth quadrant. And in the fourth quadrant, what do we do to find bearing? We remove theta from 360. I hope you remember. So, like I said, I said it earlier, you must know your theta. So the next question is, what is my theta? So I have my theta to be here. Now, what do you know about alternate angles? You know, we are told that alternate angles are equal, right? Good. So theta is equal to 61 degrees. Reason, alternate angles. So you see, now that I know that my theta is 360, I will simply remove the 61 from 360, since my theta is 61, and that will give me 9, 9, 2. Okay, so the bearing, therefore, the bearing of B from A is equal to 299 degrees. Okay, now moving over to the third question. The third question says we should find the bearing of A from B as well as B from A. Okay, so there we have two questions, and I believe that by the end of these two questions, please solve more and you will enjoy bearing. So we have this. So what do I do if I have this kind of question? Now, what I would do if I have this kind of question is, I've been given the position, here is my A and here is my B. So if it were to be me, I will start by completing this so that I will be sure of the quadrants I am working with, right? Okay. So if I complete position A, I will also complete position B. Okay, so now completing position A, I now know that the bearing of B from A is in the first quadrant, right? Okay, so bearing, let me start with the one I know first. Bearing of B from A is equal to 0.59 degrees. So what is now the bearing of A from B? I will check in which quadrant did this position land at. It landed at the what? At the third quadrant. Can you see that? That's why it's good to do what? To complete it so that you will understand the quadrant you are working with, so that you don't assume. So starting from the north, I will move until I get to this position, right? So the next thing is for me to find my theta. So now comparing these two angles, you see that they are alternate. Therefore, my theta is equal to 59 degrees. And you already know the reason, right? Reason is alternate angles. So if that is the case, remember from here to here is 180. So I will have 180 plus 59, and that will be 9, 3, 2. Therefore, bearing of A from B is equal to 239 degrees. Did you see that? So now the last but not the least, the B part of the question says, we know that the bearing of B from A is equal to 129. So the question is, what will be the bearing of A from B? So to find the bearing of A from B, in which quadrant did this position land at? It landed at the fourth quadrant. So in the fourth quadrant, what do? We remove theta from 360. So what is theta? These two angles are alternate. So my theta is also 51 degrees. So in the fourth quadrant, what do we do to find bearing? In the fourth quadrant, we remove theta from 360. Okay, so doing that, I have my 9, I have my 0, I have my 3. Therefore, the bearing of A from B is 309 degrees. I want to believe that you enjoyed this video. So let's see a thumbs up by liking, commenting, sharing, and subscribing so as to get notification on our videos. Do well to join us in the next class. Bye.